Hello students, in the last session we did complete 10 sums related to motion in a straight line, right? So in the session we will do like extra 10 more sums, fine. So as I've already told you, we need around 3 sessions to complete this chapter, right? Okay, so in the last session we saw sums that are related to average velocity and we did see sums that are related to differentiation, okay? So those were the sums basically that we saw in the last session. So in this session we will do like next 10 sums, right? So we can start from question number 11. Let's see what that question is. 11th sum is a particle of unit mass undergoes one-dimensional motion such that its velocity varies according to v of x, and then they have given which is equal to beta x power minus 2n. Okay, so that's what they have given over here. So this is actually in one-dimensional motion and they have given as an equation related to velocity. Okay, right, where beta and n are constant. Okay, as usual, and x is the position of the particle, right? So x is the position of the particle. These are something that we have known. Then you have the acceleration of the particle as a function of x is given by. So what I'm supposed to find is I need to find the acceleration of the particle in terms of x. Okay, so generally if we need to get the acceleration, what we do, acceleration is nothing but the change in velocity divided by the time interval. So that del v divided by del t. So v should actually be related in terms of time. That is when I'll be able to do the equation straight away, right? So in this situation, they have given in such a way that v is related in terms of position, which means in terms of x, it got related, right? So for this question, what I'm supposed to do is I'll just make a little bit tweaking to the formula. So the usual formula that is needed, right? So a, which is equal to change in velocity dv divided by dt. This is the general formula that we use. Okay, so here what I'm about to do is the relation is given such that v and x, therefore I'm just going to make a little change to it. I'm going to multiply dx to the numerator same way, and then I will multiply one more I will divide one more dx to the denominator. Okay, so I have like dx, therefore it will get cancelled out. What I'm about to do is I'm just going to rearrange the equation such that I'll get only x into it. So if I do a little bit rearrangement to it, for example, I'll do it such a way. So the dx by dt will be one term and the other term will be like dv by dx. Okay. So if it is such a way, then you will have a which is equal to dx divided by dt into dv divided by dx. Okay. So now I will be able to relate between v and then the x. Okay. So if I differentiate this one with respect to x, I'll get this term, right? That is done. Then what is dx by dt? Dx by dt is obviously the velocity, right? It's the straightaway one. Therefore, you have another one formula to it, just a tweaked formula to acceleration, which is like a, which is equal to velocity times dv by dx. Okay, if they've given you the relation between position and then the velocity, okay, in that situation, if I'm supposed to find the acceleration, then what I should do is I'll have to differentiate this equation once to get dv by dx, then I'll multiply this equation straight to it. That is how I'll be able to get the acceleration. Okay, right? So whatever I have told you, I'm just going to solve it, you'll get it. So next, instead of v, what I'll be able to substitute straight, I will substitute beta x power minus 2n, beta x power minus 2n. Okay, so then I'll have to differentiate this term, right? Therefore dv by dx will be something like this. dv divided by dx will be equal to, if I need to differentiate this one, beta is constant, right? So I'll get the beta straight away. Then x power minus 2n. So x is actually a variable, therefore the power comes to the coefficient. So I'll have like minus 2n x, right? Minus 2n, and then I'll have to reduce the power by 1, which is like minus 1, right? So now we have got the dv by dx, right? So let's multiply it to the velocity that I have put over here. So if I do the multiplication, you will have into beta, okay, minus 2n x minus 2n minus 1. Okay, so now if I do the rearrangement stuff, I'll be able to pick one of the options over there. So if I do the rearrangement thing, I'll have negative 2n. Okay, that is done. Then you have like beta square, then you have like x, the base is same, therefore I'll be able to add the powers. If I add the powers, I'll have like minus 4n minus 1, right? So I'll have like minus 4n and then minus 1. So that should be my answer. Let's verify it with the options. So the option should be minus 2n, minus 2n, minus 2n, beta square, beta square, beta square. That is same. Then the only thing is like x power minus 4n minus 1. So x power minus 4n minus 1 is like option 4, right? You should be clear with this sum, right? So this is like a simple sum. Only thing is you'll have to do a little bit tweaking to the acceleration formula, right? Okay. There shouldn't be any doubt in this sum. Let's move to the next one. Next sum is also the simple one. Let's see what it is. The motion of a particle along a straight line is described by equation x, which is equal to 8 plus 12t minus t cube, right? So they have given you the position equation where x is in meters and t in seconds, okay? What I'm supposed to find is that the retardation of the particle when its velocity becomes 0, right? So I'll have to find the retardation. So retardation is same like an acceleration, but the thing is they have given you clearly that the object is slowing down. So that's what they have given you here, okay? Which means you're having deceleration, right? So whenever they give you the term deceleration or retardation, you shouldn't include the negative sign. That's what this represents, okay? If they've given you like acceleration, then you'll have to include the negative sign. But in this question, they've given you clearly what is going to happen is like retardation. So when you end up finding acceleration, you'll have negative sign in it, okay? So when you are about to mark the option, you shouldn't consider that negative sign, okay? That's what they are meaning by retardation, okay? Right, let's do it. So here you have x, which is equal to 8 plus 12t minus t cube, right? So in order to get the velocity, what I do, I'll differentiate it once to get the velocity. So the velocity will be like v equals 12 minus 3t square. Okay, now I have got the velocity. Then if I differentiate it one more time, I'll end up getting acceleration. Therefore acceleration a will be like equal to minus, yeah, you'll have like minus 60, right? So now I have got the acceleration. So at what point should I find the acceleration is when its velocity becomes 0. I'll have to find the acceleration at that instant, right? So here what I'm supposed to do is I'll have to equate the velocity to 0 to get the time, and then I'll put the time into the acceleration equation. By that I'll be able to get the retardation, okay? So the velocity will be equal to 0. At that point, you'll have like 12 minus 3t square, right? So if I do the rearrangement, you'll have like 3t square, which is equal to 12. So if it get cancelled, you'll have like 4 into it. Therefore, t will be equal to 2 seconds, right? Now I have got the time, which I'll be able to substitute it over the acceleration. If I substitute it over there, you'll have acceleration a, which is equal to minus 6 into 2, which is like minus 12 meter per second square. Now I have got the acceleration. As I have already told you, you will get negative sign in the acceleration, right? But the thing that they're asking us to mark is like retardation, which means they have clearly said the vehicle is slowing down or it is moving backward. Something is happening over there. That is something it has been said clearly. Therefore, I shouldn't consider the negative sign. Just I'll have to put the magnitude. The magnitude here is 12. Therefore, the answer here is option 4. Okay. No doubt should be there in this question. Let's move to the next one. Next sum is a little bit tricky. Anyway, let's read the sum. Here you have a particle moves at distance x in time t according to the equation. So this is the equation that they have given you. So they have given you the position equation. Okay. The acceleration of particle is proportional to. So what I need to find is the acceleration of the particle is something that I need to find. They have given you the x, right? So to get the velocity, I'll have to differentiate it once. To get the acceleration, I'll differentiate it twice to get the acceleration, right? So what I need to find here is the acceleration is proportional to, which means how does it relate with the velocity? How does it relate with its distance or position? So that's what I'm supposed to find here. So to get that one, first I'll have to find acceleration and velocity in terms of this variable. Then let me find how it is related, okay? So first I'll take the x equation. So here x, which is equal to t plus 5 the whole power minus 1, right? If I differentiate it once, I'll get the velocity. So if I do the differentiation, you have velocity to be v, which is equal to negative 1 t plus 5 the whole power minus 2, right? Okay. So if you're going to differentiate the term that is inside, the t differentiation of t will be like 1, the other one is like 0. So you'll have just 1 multiplied to it, which is not needed, okay? So you do not worry about the chain rule that I need to apply here, right? Now I have got the velocity. Then I'll have to get the acceleration, right? So acceleration a will be equal to the differentiation of this one. I'll have to differentiate it one more time. So when I differentiate it one more time, we'll have like minus 2 becomes 2, and then you'll have t plus 5 the whole power minus 3, right? So this will be my acceleration. Fine. So now I am ready to relate between acceleration and then the distance. Okay, so with that I'll be able to verify option 2 and then option 3 whether it works out or not. If it doesn't work out, then I'll verify option 1 and option 4, right? So let's first verify option 2 and option 3. So I'll have to find the relation between a and then x, right? So x equals t plus 5 the whole power minus 1. So if I need to relate, I'll write it such a way that you have a which is equal to 2 t plus 5 the whole power minus 1 to the cube. Okay, so here if I do the internal multiplication, I'll have like t plus 5 the whole power minus 3. So this is like the same relation as above, but the thing is now I'll be able to put x in here, right? So if I put x here, I'll have like a which is equal to 2x cube. Fine. So a will be related to the distance in terms of cube. Okay, so now let's verify it. So option 2 is not possible. Same way option 3 is also not possible because this is related in cube, but you have like squares and 2 here, right? So that's not possible. Fine. So now what I'm about to do is I'll just find the relation between a and then the velocity. Okay, acceleration and then the velocity. So to relate it, what I'll have to do is I'll have to bring negative 2 into it, right? So let's do it this way. So you have acceleration a which is equal to 2 t plus 5. I'll just multiply by 2 in the power and then I'll also divide by 2. So you'll have like minus 3 into 2 and then divided by 2. So in the power, I'm just going to multiply it by 2 and then I'm going to divide it by 2. Okay. So now I'll factor out minus 3 by 2 in the power. So you'll have something like this. So you'll have like 2. I'll just put outside the bracket negative 3 by 2. I mean like only 3 by 2. So then you will end up having, so let's make it this way. You have t plus 5 power minus 2. So outside the bracket in the power you'll have like 3 by 2. Okay, that's how I'm going to relate it. So instead of t plus 5 the whole power minus 2, right? So instead of t plus 5 the whole power minus 2, I'll be able to substitute negative v. Okay, whatever it is, I'll be able to substitute v. That's what this represents. So the next step is actually the answer, right? A will be equal to 2 negative v the power 3 by 2. So now I have found the relation between acceleration and then the velocity. Let's verify which option is correct. V power 3 by 2, right? So in power it should be related in the fashion of 3 by 2. Therefore the answer here is option 1, right? So in this sum, what I'm supposed to do is I'll have to find the acceleration and velocity by differentiating it. Then I'll cross match it with the distance and then the velocity, and then I'll just find it out. So which option seems to be right, and then I'll have to pick the option. That's it. Fine. No doubt should be there in this question. Let's move on to the next one. 14th sum is a particle moving along x-axis has acceleration f. Okay, so you have an acceleration f to that particle at time t, which is given by a relation f equals f naught, and then they have given you some equation, right? Okay, where f naught and capital T are constant, right? So f naught and capital T are constant, whereas small t is like the time, right? Okay, so that's the variable parameter over here. Then you have the particle at t equals 0 has 0 velocity. Okay, so when it started, when time t was equal to 0, the velocity was equal to 0. Okay, when t equals 0, velocity was also 0, right? In the time interval between t equals 0 and the instant when f becomes 0, f actually represents here acceleration, and the instant when acceleration equals 0, the particle velocity vx is. So what they're asking us to find is the velocity in this situation. So I'll have to find the final velocity. That's what I'm supposed to find here, right? Now I'll have to get an integral equation to solve this sum, right? So you have acceleration over here. So acceleration a will be equal to dv divided by dt. What I'm supposed to find is the velocity, right? So velocity is something that I need to find. The particle velocity, that's what I'm supposed to find. So I'll have to rearrange this equation and then I'll have to integrate it. Okay, so if I rearrange this equation, I'll have dv which is equal to a dt, right? So I'll have to integrate it to get the velocity. Therefore if I put the integral symbol, so how does the velocity increase? So initial velocity will be like 0. That is something that they have given. It has 0 initial velocity. Therefore the lower limit here will be like 0 for the velocity. Fine. So what I'm supposed to find here is the well, a final velocity which is like Vx, I'll call it as V itself. So V is something that I need to find here. And then what was the initial time, right? So here on the right hand side you have like with respect to time, therefore the initial time was also equal to 0, right? So here the initial time is 0. So now I have got like three limits are done. So only limit missing is like what is the final time, that's what I need to know, right? So they have given you, and the instant when f is equals 0, that will be my final time, right? So I'll have to put f to 0 in the main equation to get the time over there. So if I put like f equals 0, what will I get? So let's put f equals 0 and then I'll do the rearrangement. You'll have like f naught 1 minus small t divided by capital T. So small t will be the time here. So if I do the rearrangement, I'll have something like this: 1 minus t divided by capital T, which is equal to 0, right? So if I flip it, you will have like t divided by capital T, which is equal to 1. So if I do the cross multiplication, you will have the final time t, which is equal to the capital T, right? So the final time that I need to substitute here is actually capital T, right? Now everything is set. If I do the integration on the left hand side, it's like upper limit minus lower limit. This is like only differential element is v, therefore you'll get the v straight away. So for the left hand side, you'll get the v straight away. So what should be on the right hand side? It's like 0 to capital T. Instead of acceleration a, the acceleration here is actually represented by f. Therefore, I'll substitute f naught 1 minus t divided by capital T. Okay. So that will be substituted over there. So you will have f naught 1 minus small t divided by capital T. That will be substituted, and then you will have dt. Okay. Now I'm ready to do the integration. To do the integration, so I'll factor out f naught, okay, that's like the same thing, right? And then if I integrate dt, I'll have like t, one parameter is done, and the other one is like t dt. Therefore, you'll have like t square divided by 2. So that will be like t square divided by capital T. Okay, t square divided by capital T, yeah, 2t. N plus 1 divided by n plus 1. Therefore, you'll have like 2 capital T. And then upper limit minus lower limit, right? So you'll have like upper limit, that's going to be like capital T. If I substitute upper limit minus lower limit doesn't make any sense, because when I substitute lower limit, both those terms goes to 0. So only the upper limit is enough, right? Okay. So to substitute the upper limit, if you substitute the upper limit, you'll get the answer straight away. So f naught capital T minus t square, capital T square divided by 2t, that will be like t by 2. Okay, so that will accumulate to capital T by 2. So the answer is f naught capital T divided by 2. So that will be my answer. So you'll have option to be like half f naught t. The answer is option 3, right? You should be clear with the sum, right? The answer is like option 3. You shouldn't have any doubt in the sum. It's like a simple sum only. So what we have done here is, we just integrated it, dv, which is equal to a dt. We just integrated it both on the left hand side and then the right hand side, and we got the answer straight away, right? It should be clear. Let's move on to the next one. Next is a simple one. Let's see. Motion of a particle is given by an equation. So they have given you the position equation. So instead of s, x, they have given you s here. Okay. Rest all others are just the same thing. Then you have the value of acceleration of the particle at t equals 1 second. So what I need to do here is, I'll have to differentiate this thing once to get the velocity, then I'll differentiate it one more time to get the acceleration, right? Once I get the acceleration, I'll have to substitute 1 to it. If I substitute the 1, then I'll get the answer here. That's it. These are simple sums, right? So let us do the first differentiation to get the velocity. So if I do the first differentiation, you'll have 9t square for the first term, and for the second time it will be like 14t then plus 14. Okay, now we have got the velocity. If I differentiate it one more time, I'll get the acceleration, right? So acceleration a will be like 18t, okay, plus 14, right? So if I substitute t equals 1 second, I'll get the answer straight away. So if I substitute t equals 1, I'll get the acceleration to be like 18 plus 14, right? So you have like 32. So that will be my answer. 32 meter per second square is the answer, right? These are like easy sums. You shouldn't have any doubts. Let's move to the next one. From this sum onwards, you will get sums that are related to kinematic equation. Okay. So let's see the 16th one. A ball is thrown vertically downwards with a velocity of 20 meter per second, okay, from the top of a tower. Okay, so you are just throwing it downwards. So you have given initial velocity, which means u equals 20 meter per second. Okay, it hits the ground after some time with a velocity of 80 meter per second. So it hits the ground with a speed of 80 meter per second. Okay, the height of the tower is, I'll have to find the height of the tower. That's what they are asking us to find. So in this in this question, it is pretty clear that information related to time isn't given. What they've given is like initial velocity, final velocity, and they're asking us to find the height. Okay, therefore the relation that suits the best here is actually the option, like third relation. Okay, so third relation is v square minus u square equals 2as. That is the equation where you don't have time into picture, so that relation seems to be the best choice. Okay, so I'll use that relation. We'll end up getting the height. Okay, so let me draw a diagram. You have a tower and then I'm standing over the tower, right? I'm just throwing the ball downwards with an initial velocity u, which is equal to 20 meter per second, right? When it hits the ground, it has a velocity which is equal to 80 meter per second. Okay, so this is going to be the final velocity v, right? The equation that I chose was v square minus u square, which is equal to 2as. This was the equation that I chose because you don't have any time in it and they haven't given any relation that are related to time. Okay, therefore this seems to be the best fit. So we have like v square minus u square, which is equal to 2as. I'm supposed to find the s here. V square is known, u square is known. So instead of acceleration a, I'll be able to substitute g. Fine. So you'll have to be careful with these sums. Use sign convention properly, right? So I'm just throwing the ball downwards, therefore I'll have to use negative sign to it. Therefore, and also it reaches the ground downwards. Okay, so in both those situations the velocity was like minus 20 and then the minus 80. Fine. Acceleration due to gravity was also like minus 10. Therefore, instead of for g, I'll have to substitute minus 10, right? Be careful with the sign convention. So you will have, so in this sum, even if you don't use the sign convention properly, you will end up getting the right answer. But there are specific situations where you'll have to be clear with the sign conventions, right? So it is better to always stick to the sign convention properly. Therefore, you will end up getting the correct answer, right? Okay, let's see what the answer actually is. Here you have v square, which will be like minus 80 the whole square, minus, you'll have like negative of negative 20 the whole square, okay, which is equal to 2. For acceleration, I'll have like minus 10, right? So they have given you, for g, you can put g equals 10 meter per second square. That's what I've put here. If they haven't mentioned, just look at the option. If the option seems to be like a little bit spacious, then in that situation, if the number is not so close, then in that situation, I'll be able to use like 10. Or else if the number seems to be pretty close to each other, then in those kind of situation, I'll have to use 9.8. Fine. So I'll give you one or two examples, right? While we solve sums, I'll tell you in the next chapter you'll get, there are situations where you'll have to put 9.8. okay, because you'll end up getting two answers in that option, so you'll have to be clear. But here they have just clearly gave you use like 10 meter per second square, therefore I have substituted it straight away, putting the sign convention, which is like s, which is like negative. Fine. So then you have s, which I'm supposed to find, right? So s here is actually height h. So I'll have to find the height h, right? So for these kind of sums, even if you don't use the sign convention, you will get the right answer anyway. But the point is, it is always good to stick to the sign convention. Therefore, you will not mess up any of the sums, right? That's why I'm using sign convention here, right? Okay, if I solve this one, you'll have minus 80 the whole square, which will be like 6400, minus, you'll have like 400, correct? Yeah, negative, which is equal to minus 20h, right? So if I do the solving, you'll have like negative 20h, which is equal to 6000, right? If I just solve it, you'll have zeros and zeros will get cancelled, and then these two things will get cancelled, and then you'll end up having 300, right? So 300 will be my answer. You will have like h, which is equal to negative 300. So what does this negative represents is, you are just moving downwards, right? The guy who is standing on the top is throwing the ball downwards, which means this point should be considered as origin, right? The point about which I'm going to study will be my origin, okay? So there is a guy who is standing on top of the building and he is throwing the ball downwards. So that point should be considered origin, therefore he is throwing the ball downwards, right? So as he is throwing the ball downwards, the distance that is getting covered is also in negative direction, therefore I got the negative sign here, right? So you shouldn't confuse this negative sign. The negative sign is because the origin is set at the top of the building. Okay, so as I have already told you, even if you don't put the negative sign here, you'll end up getting this 300. That's not a problem, but you have sums where you'll end up missing it, right? Therefore always use the sign convention properly. If it is like upward movement, then put positive, fine, that's it. If it is like downward, then it should be negative, that's it, right? If I'm moving towards the right, it should be positive. If I move towards the left, it should be negative, right? Sticking to the sign convention makes it easier in tougher sums, okay, right? Therefore the answer here is like option 4. You shouldn't have any doubt on this sum. Let's move to the next one. Next sum will be a little bit lengthier. Let's solve it. A stone falls freely under gravity, right? So this is like a free fall, which means initial velocity u will be equal to 0, right? So that's the first statement. Then you have it covers distance h1, h2 and h3 in first 5 seconds, the next 5 seconds and the next 5 seconds, which means in the first 5 seconds the distance covered is like h1 and the next is like h2 and the next 5 seconds will be like h3. Okay, that's what they have given you here. So what they're asking us to find is the relation between h1, h2 and h3. That's what I need to find, right? So how will h1, h2 and h3 be related? That's what I need to find here. So let's draw a diagram for it. So you are going to drop a ball which is like a free fall, okay? So initial velocity u will be equal to 0. So you are dropping it such that it covers a distance h1. That's for the first 5 seconds, okay? So here the t was equal to 5 seconds. In the next 5 seconds, obviously the distance is going to be greater when compared to this h1. So that distance is like h2, okay? So then you have for the next 5 seconds, this part of the distance will be like h3, okay? So this is what they have given in the question. What I need to find is how does h1 and h2 and h3 gets related. That's what I need to find here, right? So in order to get the relation, first I should know what are all those heights, right? h1 what is it equal to, and then h2 what is it equal to. That's what I need to find. So first, in order to get the h1 with respect to time, the kinematic equation that I will be able to use is like s equals ut plus half at square, because in that's the equation where distance and then the time will get related, right? So h1 will be equal to h1, which is equal to ut plus half at square. That's the formula I will use. Here u is equal to 0, right? Therefore the first term goes to 0. You are just left with the second term, which is half g. Instead of t, I will be able to substitute 5. So you'll have like 5 square, right? You do not want to worry about the negative sign here, because anyway I will take the ratios, it will get cancelled out, right? Therefore half g 5 square is enough, right? So now let's find the second height, which is like h2. So to get this height h2, what I need to do is I need to have the entire height and then I'll have to subtract h1, right? So let's consider this entire height to be h2 dash. Okay, so this is like h2 dash, fine. So to get the height h2, which will be the height covered in the next 5 seconds, right? So to get this height h2, what I'm supposed to do is I'll subtract h2 dash minus h1. That's what I'm going to do here. So h2 will be equal to h2 dash minus h1. Fine. So h1 is already known, which is like half g 5 square. Then what should be the h2 dash? It should be something like this. So I'll write it here. So you'll have h2, which is equal to h2 dash will be like half. So g, that's going to be the total time, right? So total time is 10 seconds. Therefore, I'll put 10 square. Okay, minus half g 5 square. That's what you'll get, right? So when you do the math, you just factor out half g and then you'll have like 100 minus 25, which is going to be like 75, right? So h2 will be equal to half g, just factor out half g. So inside the bracket you will have like 100 minus 25, that's going to be 75. Now I have got the h2, then I'm just left with the h3, which I need to find here. Okay, so to get the h3, as usual, you just consider this complete length and then subtract it with h2 dash, you will end up getting h3. Okay, so to get h3, I'll just put it straight away. You should be able to understand this one. h3, which is equal to half, okay, g the total time taken, right? So the total time taken will be like 15 square. Okay. Yeah. So the total time taken will be like 15 square minus the H2 dash, right? So the H2 dash will be half G 10 square. Okay. So if I do the math, 15 into 15, right? So 15 into 15 is like 25. 2, this is like 75. Yeah, right. So this will be like 15. So you'll have like 5. This will be like 2 to 5. Okay, so you got like 2 to 5. Okay, so if I substitute this one, I'll get the H3. So H3 will be equal to, I'll factor out half G because that is the same thing. So you'll have like 2 to 5 minus 100. Therefore, that's going to be like 1 to 5. Right, so now I have got H1, H2 and H3, right? So I have got the final relation between H1, H2 and then H3. Now I am ready to take the ratios. So if I do take the ratios, it will be like H1, you will get H1 is to H2 is to H3, right? So when I take the ratios, the only parameter that will be left is like, for the first one, that's going to be like 25. Okay, that's the only thing that will be left. Rest all other things will get cancelled out, right? So we'll have like 25 in the first H1. For H2 you'll be left with 75. So 25 is to 75 is to 125. So that's what you'll get, right? So if I cancel it out, then you'll have like 1 is to, so 3 into 25 will be like 75. So that's going to be like 3, and then 5 into 25 will be like 1 to 5. Therefore 1 is to 3 is to 5. So this is the ratio that's needed, right? So now what I need to find is I'll have to get the relation out of it, right? So the relation, in order to get the relation, let's relate everything with respect to H1. So let's do it. So for the first one, it will be like H1 divided by H2. What will it give? H1 divided by H2 will be equal to 1 divided by 3, right? Therefore, this implies H1 which is equal to H2 divided by 3. So that's the first thing. So if I do it the same way, for H1 divided by H3, I'll end up getting, H1 which is equal to H3 divided by 5. Okay, that's what I'll end up getting, right? Okay, correct. So now let's relate it. If I relate it, H1 should be equal to H2 by 3. H1 should be equal to H2 by 3. So the only thing that is possible is like option 4, H1 which is equal to H2 by 3. And then same way H1 is equal to H3 divided by 5, right? So that's what I have got over there. Therefore, the answer for this question is like option 4, right? You should be clear with this sum, right? So this is a little bit lengthier and exhaustive sum. The thing that we have found is the relation between those 3 different heights, okay? You should be clear with this sum. Let's move on to the next one. 18, the sum is simple one. Let's see what it is. A boy standing at the top of a tower of 20-meter height drops a stone. Okay, so there is a guy who is standing on a tower and he is dropping a stone, which means the initial velocity u equals 0, right? It's a free fall condition. Assuming g equals 10 meter per second square, the velocity with which it hits the ground. So I'll have to find the velocity with which it's going to hit the ground, right? So time isn't something that comes into picture. Therefore, I'll use the third kinematic equation, which is like v square minus u square, which is equal to 2as. I'll use that equation. Here the initial velocity obviously equal to 0, right? So the initial velocity is 0. What I'm supposed to find is the velocity with which it's going to hit the ground. That's what I need to find here. So if I do the math, you'll have like v square, which is equal to 2. Instead of g, I'll be able to substitute minus 10. And the height of the tower is like 20 meter, right? So he's dropping the ball downwards, as I've already told you. That too is in negative direction, okay? Therefore, he'll have like minus 20, okay? Right, now I have put everything into it. Now I'm ready to get the v square, right? So if I get the v square, velocity v will be equal to, if I do solve this one, it's going to be like root of 400, right? So root of 400 will be like v, which is equal to 20 meter per second, right? As it is in square, and then I have taken root here, you will not get the direction here, right? So minus minus it becomes positive, and then we will be able to take the root. If it was like negative inside a root, that will be like an imaginary term, right? So that doesn't matter anyway. These are like simple sums, right? Well, in just one step you'll get the answer. Therefore the answer here is 20 meter per second, which is like option 2 in the situation, right? These are easy sums. Let's move to the next one. Next sum is a ball is dropped from a high rise platform at t equals 0, right? So there is a guy who is standing on a tower and then he is dropping a ball, which means initial velocity u is equal to 0. Starting from rest, fine. So the initial velocity is 0. After 6 seconds, so he has dropped the first ball. After 6 seconds, another ball is thrown downwards from the same platform with a speed v, right? So which means in the first situation, he has dropped a ball, which means initial velocity was 0. In the second case, after 6 seconds. So first he has dropped a ball and then after 6 seconds after it, he is dropping another one ball. Okay, so with an initial speed v, which means he is throwing downwards with a velocity v, right? The two balls meet at t equals 18 seconds, which means those two balls are meeting each other at the 18th second with respect to the first ball that he has thrown. Okay, what is the velocity? What is the value of v? So now I need to find the velocity. The initial velocity of that second ball is something that I need to find here. Okay, so what I'm doing here is you are just dropping the first ball. Okay, and then when time t equals 18th second, okay, so it has reached certain distance. The same way, I'm just throwing down another one ball with some initial velocity v. Okay, obviously I'll have to throw it downwards or else these two things will never meet. Therefore, he is throwing the second ball downwards after 6 seconds. Fine. So those two balls in the situation he is throwing from the same position. Therefore, those two balls meet each other at time t equals 18 seconds with respect to the first ball. So for the second ball, the time it has traveled should be like 18 minus 6, right? You should get the logic. Therefore, for the second ball, the time will be like, for the second ball, time will be like 18 minus 6, which is like 12 seconds. Okay, so for the first ball, it would have traveled 18 seconds in the air. I have thrown the second ball after 6 seconds. Therefore, it should have traveled just 12 seconds. Okay, so at this point, both those balls meet each other. What they're asking us to find is what will be the velocity of the second ball with which I have thrown it downwards, right? So I'll substitute this in the equation and I'll get it, right? So obviously the equation that I need to use is s equals ut plus half at square. I'll put all those sign convention as the way it needs to be put, right? I'll include all those negative sign and I'll have to solve it. While solving it, the end result will be negative, which means I have thrown it downwards with certain velocity. That's what that will represent, right? So let's do this sum. For the initial case, for the first condition, if I put like s equals ut plus half at square, let's make it this way. That's like s1, which is equal to ut. Initial velocity was 0. Therefore, the first term is just gone. The second term will be like half. Okay, so instead of g, they have given to substitute 10, which will be like minus 10, and the time will be like equal to 18 square, right? So now I have got s1, which is equal to half minus 10, 18 square, right? So here I have got the s1. Then what I need to find is like s2, right? S2 will be equal to ut plus half at square. You have initial velocity. I have thrown it downwards. That is when those two things will reach. So the initial velocity they have given here is like v. Therefore, I'll put v into the time. Time will be like 12, right? Only 12 seconds the ball has traveled. That is when these two distances s1 and s2 will be equal. Therefore, obviously, the time that I'm about to substitute here will be like 12. Okay, so you have v into 12, right? The first term is done. Then you have like minus half. Instead of g, I'll substitute 10. And then for t square, I'll be able to substitute 12 square, right? Now I have generated the equation. So I'll have to equate these two equations because what is the value for v when both those balls meet? Okay, when both those balls meet at t equals 18 seconds, what should be the velocity? That's what they're asking us to find. Therefore, it has met, which means s1 should be equal to s2. That's the thing, right? So if I equate those two things, I'll get half negative 10. So minus 10 and then 18 square, which is equal to 12v minus half 10 12 square, right? So if I do the rearrangement, I'll have 12v, which is equal to, which will be equal to half 10. I'll do it straight away. I'll just factor out half 10 from it. So I'll have like 12 square, okay? So if this term goes to the left hand side, you'll have like 12 square. Then obviously you'll have negative 18 square. Fine. So that will be left, right? So these two things will get cancelled out. Fine. So these two things will get cancelled out, and then you'll have like 5, and then this 12 will come to the denominator. Before that, we will do the math here, right? So the next step will be 144, right, minus 18 square. So if I multiply 18 into 18, 64, 6, 8, so that will be like 144, right? Yeah. And then you have 18 into it. So you'll have like 4, and then you'll have like 2, 1, so you'll have like 3 to 4, right? So here you have 3 to 4, right? I'll have to subtract these two things. So if I subtract it, I'll have like 1, 4, 4. This will be like 0. So here it will be like 2 and then 12, which is like 8. So you'll get 180, right? So you get 180. Yeah, so V will be equal to 5 into 180 divided by 12, right? So you'll get the negative sign, obviously, because negative is dominant here. Therefore, I'll put a negative sign here. So this negative sign clearly represents that I'm throwing the ball downwards, right? So that negative sign automatically pops from the equation because I have substituted all the values in proper direction. Therefore, this negative sign clearly comes, right? If it was like positive, then it means I have actually thrown it upwards, but that shouldn't be the case, right? I have clearly thrown it downwards. So you have to be very careful with the signs. That's why always when you solve sums, just stick to the sign convention, because anyway you will end up getting the right answer. But if you just do it mind calculation, there are times when you will end up messing up the signs, okay? So you'll have to be careful. All right, if I do the solving, you will have, this will be like 60, right? And then this will be like 4, yeah, right? So then 32, and then you get like 15. So 15 into 5. So 15 into 5, right? I'll do it. So 25, that's going to be 75, right? The velocity here is minus 75 meter per second. Velocity will be like 75 meter per second. The answer here is like option 1, right? So what is the value of V? Just they're asking us to find the magnitude. Therefore, that's going to be like 75 meter per second, right? You should be clear with these kind of sums, right? So this is like a little bit tricky, and then it is also lengthier to solve. I hope you did understand the thing that I've solved here, right? There shouldn't be any doubt. Let's move to the next one. Now we are into the last sum of this session. Let's see what it is. A particle starts its motion from rest under the action of constant force, okay? So a particle is moving under the action of constant force, fine. If the distance covered in the first 10 seconds is S1, and that covered in the first 20 seconds is S2, then. So what they have given here is a particle is moving under a constant force. In that situation, what will be the distance covered in the first 10 seconds to that of the first 20 seconds? That's what I need to find here. We haven't dealt with the term force as if now, right? So we'll do force in the third chapter, okay? Which means in laws of motion, we will do force. From the lower grades, you should know F equals ma, right? So if F is equal to ma, then here what they have given is constant force, which means force on that object is constant, right? On that object or particle is constant. That's what they have given here. If force is constant, obviously the mass of the object has to be constant. Therefore, acceleration is constant here. So instead of giving constant acceleration, they have given you constant force. That's it, right? Small tweaking to it, right? So here this sum is actually a constant acceleration sum. Therefore, I'll be able to use kinematic equations, right? So if I'm about to use kinematic equation, so the data here is like S and then the time. Therefore, I'll have to use like second kinematic equation, which is S equals ud plus half ad square. That's what I'm about to use here. So for S1, you'll have ut plus half at square, right? So the initial velocity here is 0 because it starts from rest. Therefore, the only term that you will be left with is half. Okay, a instead of t, I'll substitute 10 square. The first one is done. For the second term, which is like s2, I'll substitute half a. So instead of t, I'll substitute 20 the whole square, right? Now let's do the cancelling stuff and I'll get the answer, right? So if I do the cancelling stuff, I'll have half it will get cancelled. Same way, a it will get cancelled, right? So the only thing that is left is like 10 square divided by 20 square, which will be like 100 divided by 20. So 100 divided by 20 will be like 1. I'm like 100 divided by 400, which will be S1, which is equal to S2 divided by 4, right? Therefore, S2 will be equal to 4 times S1. Okay, so S2 is equal to 4 times S1. The answer here is option 2, right? These are simple sums, right? You shouldn't have any doubt in these kind of sums, right? So the things that we have seen in this session, the sums that were mainly related to kinematic equation. Okay, so we did see all those kind of sums, right? So you shouldn't have doubt in the sums that we have seen. In the next session, we will do sums that are main related to relative motion, and some leftover kinematic sums will also be dealt. Okay, same way we'll do sums that are asked in 21, 22, 23. Those 3 year sums will also be done in the next session. Fine. So with this, the video gets completed. Bye.